the amazing part of what Iridium has done is delivered on exactly what it said it was going to do 15 years ago when we started down the approach of repopulating the satellite constellation network. And Aireon was always a piece of that strategy at the time. If you think about where you guys are now from a financial perspective, I'm sure you've heard Matt say this before. The company 15 years ago was not in a place to very easily finance a $3 billion satellite replenishment at the time. And one of the areas that we thought would be a potential way to help finance the repopulation and large capital investment you guys would need to make was to do something new with the satellite constellation. Take this phenomenal asset you guys had for providing communications from anywhere to anywhere in real time, and make it available to other things more than just two-way voice and data communications around the world. And that concept that we put forward was, let's go rent space on each of those new satellites to someone else, right? To a government agency, to a commercial company, et cetera, to make use of this asset. And for those that were there at the time, we had probably over 30 different studies that we did, some paid studies for government agencies, other were commercial, and civil agencies, obviously commercial opportunities as well. And it turned out, two things. One, government couldn't move as fast as Iridium at the time. We had made a commitment to a satellite manufacturer. We had made a commitment to a launcher, a launch provider, and you couldn't wait for the government to make up their mind for some of the space on board the satellite constellation. But in the meantime, we had come across some study work that was going on with a new technology for air traffic control that Peter will talk about, that enabled basically tracking of aircraft that were already equipped or were going to be mandated to equip a device on all those aircraft that sent out its location information and other useful information at a very rapid basis. It's a technology with an acronym, ADSB, or Automatic Dependent Surveillance Broadcast. And the interesting thing about this, I remember a meeting that I had with Matt just in the hallway, and we said, yeah, we heard about this technology called ADSB, and Matt goes, what? ADSB? Because obviously, as everybody knows, Matt's a pilot. He said, this is the new way of doing air traffic control surveillance. And he really kind of encouraged us to pursue that. Needless to say, we did, and because there was an opportunity that we saw from a commercial perspective to basically create a new global capability for air traffic control that never existed before, and that Iridium had the kind of intelligence to see this, and the Matt and the board were interested in helping get this going. They gave us some walking around money to go explore it from a technology perspective, from a business perspective, and it all came together just at the right time, and we were able to raise the money and spin Iridium out as a separate company, obviously closely related to Iridium for a long time. We were located right with you in HQ offices until we eventually ran out of room over there, both from our perspective and you guys were hiring too many people to fit in that space. But so a lot of progress in that time over 10 years, that we worked with you guys in building out the system, deploying the system. And I'm going to introduce Peter Cabooter, our VP of Sales and Marketing Customer Affairs, who really is spearheading the adoption of this capability across the entire aviation community, not just the air traffic control area. So phenomenal ride, and it couldn't have happened without Iridium's support and Iridium's foresight to say, hey, this could really be a game changer, and giving us the backing, and of course giving us the ride and the place to freeload on your satellite network to operate our system.
Thanks for that intro, Don. As the cliche goes, a picture always says more than 1,000 words. So let me just start before we go into a few slides. So don't worry, we won't kill you by PowerPoint, but I wanted to show you this. So this is obviously a map of a kind of a demo setup that we usually show customers. You can see here that we're tracking currently more than 13,000, targets. Every white dot or box or square that you see on the screen actually is an aircraft. So this is something that looks maybe very straightforward, but it absolutely is not. You have to imagine that in order to have surveillance capabilities of an airspace, before Aireon existed, anyone needed to put some form of ground sensors, whether that's primary, secondary radar or ground-based ADS-B, obviously on the ground to look up, to look at the airspace and to see what was happening there. Because indeed, like Don mentioned, the visionary decision was taken to put this technology onto satellites. We basically now have a capability to look down. So that means we can basically see all the aircrafts that are equipped with that ADS-B equipment on board, which is probably globally around, I would say, depending on the region, probably around 98, 97% of the world has this, at least for the commercial airlines. And more smaller aircrafts are also adopting that, including helicopters. We basically see everything. So I'll just zoom in so you can kind of get a sense of this type of demo setup, where you see now in an oceanic area where before there literally was no way of having surveillance capability, we track all these aircrafts in real time. So that's really, I mean, it's phenomenal. If you show this to customers, we typically see more of what they actually see themselves. And I'll just zoom out just to give you some idea of what we're looking at here. For example, you can even see here an aircraft. This is on top is like the call sign or the identification. Then you have flight level. So this is an aircraft at flight level 5, and the speed is right underneath flight level 4. So this is going to be a helicopter that is actually landing on an oil rig in the North Sea. So just to give you an idea, as I said, we see everything from the ground all the way up, and we do that instantaneously. So because of the power of the constellation and the payload that we have, we basically are able to relay those signals as quickly as we pick them up from the aircraft, bring them to one of our customers' facility, and we do that with a latency on average globally of about 1.5 seconds. So, and in some cases even like 200, 300 milliseconds. We really have a really good performance in that regard. So just wanted to start by showing you that, because I think it shows exactly, let's say, the value and the power of what we're providing to our customers. So now let me just take you, as I said, to a few slides. Some of this might be a little bit repetitive, but anyhow, so the company was created in 2011. We are, of course, we have our payload on the Iridium constellation. Our system actually went live with certification, and I'll come back to that, in March 2019. And obviously, we have a payload on every of the 66 active satellites that are orbiting the globe. So, as Don mentioned, we started the company very much in this domain of what we call ANSPs, Air Navigation Service Providers. These are organizations that are responsible for the airspace of a country, or sometimes even a combination of countries. So they need to make sure that they can provide a service to the airlines that are operating in that airspace. Their first mission is always to do it safe. So they need to be able to separate aircrafts according to the right standards to make sure that everyone's operating safely in the airspace. And then the second to that is do it as efficient as possible. So the more technology you have into that airspace, and that's surveillance, it's communication, it's navigation capabilities, the more efficient you can actually use that real estate in the air, so to speak, to have those aircrafts operating as efficient as possible. Currently, so since March 2019, where we currently are, there are 21 of those ANSPs, so those air navigation service providers, that are using our data, and they represent more than 40 countries in a day-to-day setup. So what does that mean? Literally, we have, as you probably know, whether you're an aviator or not, if you travel, everyone knows the site of an air traffic control tower. In that air traffic control tower, you have air traffic controllers that are managing aircrafts that are within their responsibility. You also have bigger centers that are looking at upper airspace. So this is really typically where we would put our data in front of those controllers, and they use our data to separate airplanes. So this is extremely critical from a safety point of view. And they obviously rely on our data to be accurate and to always be there. So it's not like, oh, we do it from 9 to 5 and then in the evening we'll see. No, this is really something where these people are using our data, and it needs to be accurate all the time, and it needs to be reliable, it needs to be precise, and the signal always needs to be there because they're relying on it on their day-to-day. So there's a couple of examples underneath. But I have a slide that kind of gives a bit of a better overview of that, so I'll go into that later. The last let's say thing that you see here on the slide to the right are commercial services. So the company was created very much for the use case that I've just explained, so to use our data for separation purposes. But we see much more use cases of our data that are slightly different. So we've launched some capabilities in October 2020, and I'll talk about those as well. But you can consider that we are basically using the same data provenance, the same data quality, but we're providing it to customers that are using it in a less safety critical environment, but nevertheless, they are looking for very precise data. So I'll come back to that. But that's kind of the way to look at it. The ANSP business or vertical is, let's say, the bread and butter and the reason why Aireon was created as a company. And then now we're venturing much more into those commercial services as well. So an important, I won't go through everything here. The main thing to remember from this slide is really the business case and the business model that we are using towards those customers is completely different than what they are used to. As I mentioned, typically these type of air navigation service providers, they need to buy equipment, install it, maintain it, have engineers to go out a few times per year to do maintenance on it and make sure that everything is operating well. So that means in order for them to have that technology or that capability available to them, there's a big investment upfront. They install it, then they operate it for sometimes 10 years, 15 years, 20 years. Then they buy a new one, and like that, they basically continue. Our business model is completely different and completely new for this type of usually conservative market. We are doing a pay-as-you-use type of model. So we're saying, look, this is data as a service. We are guaranteeing the quality of the data to you. And if we are providing that data to you at the quality that we're telling you it's going to be, you pay us at the end of the month based on the flight hours that we're operating in your airspace. So the example, of course, comes to mind in this whole the past COVID situation. Many of our customers were quite happy that, of course, as their traffic went down, their revenue went down, but also their invoice to Aireon went down. Obviously, for us as a company, we would have preferred for those amounts to stay as high as they were before. But nevertheless, it speaks to the flexibility that we have in the model to kind of work together with our customers. As they grow, we also grow together with them. So it's really that type of service volume, which also helps us with the positioning, because many of the suppliers that are operating in this space, they kind of sell, they try to get the maximum from their customers, and then it always becomes complicated afterwards if customer wants something more, they need support. For us, it's a completely different approach. We are saying, look, we are here with you. We are sending you an invoice every month, and we want you to be happy and pay that invoice with a smile. So that means from a service point of view and the way we collaborate with our customers, there is I wouldn't say day to day, but at least we talk to all of our customers every second or every third day to make sure that everything is running smooth and that we can kind of help them with whatever, whether technical questions, admin questions, or anything else. We are very close to those customers because, again, we want to make sure that they stay with us for a really long time and that they're happy to be a partner of Aireon now and in the future. So that's kind of a revolutionary way of having a business model in this vertical, because these customers, these ANSPs, were absolutely not used to doing this. And we see a shift not only in our technology, but also other players in this domain are now also operating more in that type of service model. We all see it in our personal life. So for us, it kind of goes without saying that you see this in this type of technology fields also. Okay. So this is a nice, I mean, I'm pretty sure that people on the call here kind of know this probably much better than we do, but this is obviously the satellite constellation that provides pole-to-pole coverage from the service surface all the way up. So again, the top side of the slide, I probably don't have to talk too much about. Again, I think there's people that are smarter than me on that on the call here. But in essence, it's really an aircraft is transmitting on a 1090 megahertz. Anything they send, we capture. We then relay that message, obviously using the Iridium constellation to bring that back down into a HPOC, so the Hosted Payload Operations Center. And then the last portion you see here, which we call SDP, is a dedicated telco connection that we provide with some hardware, but very limited, into the customer, those ANSP's facilities. So we would integrate our data signal into their existing platforms. So they typically have a system that the controllers are working on. It has displays, and of course it has like weather information and planning tools and all of those things around it. So we would integrate our data into their platform, which makes it seamless for them to work on. So whether the signal for that type of air traffic controller, whether the signal comes from another sensor or from ours, it actually doesn't really make a difference to them. They're seeing a target on the screen, and they know that they can rely on that target. So that's kind of how we deliver that dedicated to that type of customers. You will see in like 2 or 3 slides for the commercial use of our data. That's slightly different because this requires, as I said, some hardware, so routers, firewalls, and dedicated MPLS connections to be able to bring that data in a secure way to the customers. Sometimes you combine with VSAT, so there's multiple ways to do it, but it's a very secure, dedicated, monitored way of providing data to customers. In the commercial field, obviously, we want to make it a little bit more easy for customers to get their hands on our data. So I'll talk about that in a couple of slides. This is giving you an overview of those 21 ANSPs that are using our data, as I mentioned, day to day, so 24/7, every minute of the day. And they basically represent more than 50% of the world's airspace. So, of course, we are still growing, and we are signing more and more customers, let's say, every year. But that's where we are currently. So you see a couple of maybe more well-known names like NATS in the UK, NAV Canada, that are using our data in a very important use case in the North Atlantic. So imagine this, many people don't know, but before Aireon existed, the North Atlantic did not have surveillance coverage. So the way to look at this is that they used to do what we would call procedural separation, which means you decide in which corridor you're going to send an aircraft over the North Atlantic. You tell that aircraft which speed it needs to fly, and then basically you wait long enough to put the second aircraft at the same speed through the same corridor. So there's a very rigid way of managing it, but it's safe. So adding our signal, our data to that type of operation allows them to do 2 things. It allows them to have those aircrafts fly closer together, of course, still far enough from each other to be safe, but closer together. So you increase capacity. And second, you can kind of provide more flexible routing. So you can look at jet stream, weather conditions, and just provide more direct routes. So that means aircrafts are flying shorter distances and shorter time, which everyone likes because it's good for the environment, it's good for the fuel cost of the airline, and also, of course, for the ANSP, they like it a lot because it's a safer way of managing traffic. So that's on one side of the equation, what I would call like the more higher end type of our customers. You also see a symbol there that says New Sky Pacific. This is the ANSP of Papua New Guinea. They have a completely different use case. Their use case was much more around, okay, we are an island group. If we put sensors on the ground, there's a few things that happen. First of all, we have an issue with line of sight. There's a lot of mountains. So if you put a sensor on the ground, it can be blocked by mountains that are in between. Second, there's also a lot of tribal, let's say, ground there still. So even though the land is owned by the government, they would install sensors on the ground, and literally the next day they would be burned down because there's a tribe left or right that doesn't agree that the government puts assets there. So they will basically burn it down. Or in other instances, they had examples where people are actually breaking into those facilities overnight to steal the copper wires that are in there, because we all know what the prices of copper are these days. So this is a completely different use case, and this is a customer that was struggling to be able to have that surveillance coverage over all the islands because of the reasons I just mentioned. So it's very much between those very high-end customers that have a very high demand for our data and for the way they use it, to smaller organizations like in Papua New Guinea that are operating, let's say, in a kind of a different environment, but still the data is still very, very important to them. I'll also show you an example of Norway, where they are actually using our data specifically to monitor helicopters, right? The helicopters that go out into the sea to the gas and oil platforms. They wanted to provide a service to those helicopters to be able to monitor them, again, to increase safety. And that's then their use case. So it's a whole mix of customers using our data in an oceanic environment. Other customers are using it for like more remote or domains or areas with terrain challenges. Then we have other customers like ASECNA that you see in the bottom left, is an organization that represents 18 countries in Africa. And there they made a deliberate decision, instead of they're covering a really, really big airspace, even terrestrial, instead of investing all these to install all of these ground sensors and maintain them and having the people to actually service them, they said, okay, let's leapfrog, if you like, go from we don't have anything, and instead of investing into ground sensors, they immediately went with space-based ADSB to be able to service their customers and to have surveillance capability. So, and then literally everything in between. You see there Singapore, Hong Kong, the Irish, the Italian. So there's a whole bunch of different use cases there. But in what brings all of this together is that all these customers are relying on our data, as I said, in their day-to-day operations, and it's safety critical. So the data needs to be always there and needs to be very accurate. This is another like picture of let's say some of the tracks. I put some color coding in there to show you altitude, but this is really what we are seeing on a day-to-day basis in terms of global traffic. So we really cover everything, and you can obviously tell that there's big differences in terms of density. Again, looking at the North Atlantic here, or then if you look at parts of Africa, for example, it's a whole different ball game. But still, those customers are using our data day to day. This is the example I wanted to give you in Norway, specifically for those helicopter operations. So it looks very different, of course, than what I would call normal commercial traffic. So these are these helicopters that go back and forth to bring crew onto these platforms, and our data is being used to do that in as safe as possible. So to make sure they have complete control over who is flying where and when. Just from a service point of view, but also from a safety point of view, if something would go wrong, they obviously have a very precise location of all of those helicopters flying in that Norwegian Sea, let's say. Okay. I won't go too much into detail, but we made a very deliberate decision to receive an AYaza certification. So this is really a European agency for safety, if you like, that provides a certain set of requirements for a European ANSP to be able to operate. So our customers look, for example, at NAV Portugal, so the Portuguese ANSP, before they are allowed to provide services in their country to manage aircrafts, they need to go through this AYaza certification. We as Aireon, we did exactly the same. So we have the same level of certification as our European customers do. This helps us in a few ways. This helps us, of course, to kind of underline the quality and the quality assurance that comes with our data, but it also helps with our customers that want to use our signal into their airspace, because typically an ANSP that buys our data and uses our data for separation purposes, they will also need to have their local regulator approve them to use that signal. So that means they also have to have a local safety case that describes how are they integrating the signal, how are they going to use it, what are the separation standards, so what are the rules to kind of bring or separate those aircrafts from each other. That's a safety case that basically describes how they would do that. Of course, doing that based on a surveillance capability like ours that has that certification already makes it a lot easier for them to convince their local regulators to kind of say, look, these guys are already certified. These are all the customers that are already using the data. So the delta to actually get their approval in a regional or a local way becomes much smaller. So it goes, I wouldn't say it goes quick, but it goes quicker than if they would have to start from scratch, so to speak. So this is a really an important component. We get audits. We started with 4 audits per year. Now we have 2 audits per year, where AYaza comes in and looks basically at everything from the way we manage the data, the way the system is operated, all the documentation, anything, let's say, as a company, the way we operate to make sure that they can keep giving us, let's say, that approval stamp, that we are basically doing everything we can to maintain the quality and the data provenance, let's say, of the service we provide. So that's kind of, as I mentioned, the initial use case. So the bread and butter of, okay, why was Aireon created? Then we went into what I would call the commercial data services. So as I mentioned, that's not for ANSPs to separate aircrafts, but for other use cases. So I'll give you a couple of examples. I'll first, as I mentioned, describe to you the difference between how we deliver the data to that type of customers. So you'll see that obviously the first parts are all the same. It's only at the end that we kind of make a change, and we basically provide our data over the cloud to these customers for them to have easier access to our data. So it's really, you don't need those telco connections. You don't need to have all of that installation and validation done. We provide the data on the cloud, and that's basically how those customers would connect with our data and have access to our data. So the portfolio that we launched end of 2020, basically we're doing that into 3 different components. To put it into perspective, Aireon Stream is really streaming data. So the same data that you've seen before that is used by ANSPs. Sometimes it's relevant for other type of organizations to be able to have a situational awareness, whether it's from a piece of airspace or a specific fleet of aircraft. Sorry for that. So an easy example there, sorry, is an airline that has an interest to track their fleet. So they want to know where their aircrafts are flying. So in their operations center, they have a big display where the dispatchers are working on and their planning people are working on, and they see where all their aircrafts are flying constantly. Need to get some more water. Sorry for that. So this gives you a quick reference, but as I said, I'll give you some examples. So this is Aireon Stream, as I mentioned. It's for flight tracking, for example. So this is a market we approach through partners. So we have multiple resellers that are packaging our data into their capabilities, into their products, if you like, to provide that type of flight tracking capability to airlines, operators, cargo operators. So there's a multitude of different kind of customers there. We also have a product we call Airspace of Interest. So it's actually doing the same, but specifically looking at an airspace. Sometimes it could be a region. So let's say a DoD type of customer, or in the IC community, they would be interested of having let's say a broader view of an airspace, sometimes even globally, to understand, okay, where are these aircrafts flying, what is happening, so they can define it, they can slice and dice it, if you like, the way they want in terms of altitude and in terms of geographic zone, and we can provide that data streaming to them. So that's really the way to look at this type of streaming data. So this gives you a bit more insights into the data coverage. So obviously it's globally. We deliver that over the cloud, as I mentioned. So the latency also there is very small. So we guarantee less than 5 seconds, but in reality, it's going to be much better than that. It's probably more like a 3-second latency that we're seeing there. Second example is Aireon Insights, and this is really the additional layer of intelligence, if you like, on top of the surveillance and the positional data that we have of these aircraft. So this can be used in a historical way. So an example to give you is, for example, Boeing, the Boeing company and their safety department, they are interested to know of a very large part of the Boeing fleet, how those aircrafts are being flown, where and from where are they coming, where are they landing, but how many cycles, what's the speed that these aircrafts are operating on. They've created a model with a whole bunch of very complicated algorithms that eventually wants them to be able to predict safety risks on specific airframes or specific configurations. So what they do is they feed our data. So we deliver them next day data. So every morning we deliver them the batch of about, I think we're currently operating around 6,000 of their fleet. We create a batch of that data of everything that happened the day before. We send it to them. They ingest that data and feed it into their models to kind of do risk assessment on how they basically how these aircrafts are being flown and what the risk would be for safety. So this is everything, as I said, with regards to cycles, but also what are we seeing in terms of patterns of how are aircrafts landing, at which speed are they landing, for example. So look at all the 737s. What's the speed that we're seeing that these aircrafts are having on final approach, and then they can start to go in more in depth to kind of say, we're seeing one specific airport or one specific operator is always operating at the speed that is slightly higher than the others. So okay, that's something that they would then want to look at. Okay, is this a training issue or what are the reasons that those things are happening? So you have the same on the engine manufacturing side. So a GE or a Rolls-Royce that are producing engines that are on aircrafts, they are interested to know, okay, how many cycles are these engines actually doing? How much time are they spending climbing, descending, and level flight? So that helps them, of course, then to look at predicting maintenance, and again, kind of looking at their customers using the engines, looking at, okay, if they're flying, for example, more in airspaces like Indonesia, where there's more, because of volcanic activity, there's more dust particles in the air. So then we see, okay, for those aircrafts that are flying there, the risk is going to be higher, and you probably need to do more maintenance. So there's a whole bunch of that type of activities or analysis, let's say, that they can do with our data as the underlying, let's say, layer. They know that our data is extremely accurate, so all the analysis and the conclusions that they get from that data obviously helps them to make better decisions, and they know that they can rely on it. This is another example, an aircraft, especially commercial. So the aircrafts we all get on as a passenger, so to speak, they have what is called TICA, so it's traffic collision avoidance system. This is literally like an aircraft is constantly monitoring whether another aircraft is getting too close to him, yes or no. So usually this obviously is not supposed to happen, but in some airspaces, especially like in the approach with the final phase of the flight, sometimes you see that there are errors there. So then the aircraft will basically generate an alert in the cockpit that says, okay, you're getting too close to someone else. So then they can immediately take action to obviously avoid that traffic. That alerting is part of the ADS-B message. So if there is an alert that the aircraft is generating, we see it in the ADS-B message. So obviously that allows us, again, more in the safety analysis domain, to kind of go to these countries or the specific airline or specific regulators to say, this is a report that we've created. We're seeing that there in airport X, there's a higher risk. We're seeing more of these TICAS alerts than what you would see usually. So this is all information we can provide to our customers, and that again will help them to operate the airspace more safely, or to operate as an airline more safely, and be able to use our data to really know, okay, where do I need to focus on, which operations are running smooth, and where are the domains that we have room to improve. So that's more on the safety side, but there's a whole bunch of, let's say, the menu of those KPIs that they can actually measure and get alerting on even. That's a pretty broad menu, and we allow our customers, of course, to decide what is relevant to them and what exactly they want to track. That's also something that we're spending a lot of effort on now, looking forward, to increase those capabilities, safety, operationally, also in the environmental domain, to kind of say, okay, how much CO2 is being emitted, what are we seeing there in terms of efficiency and impact on the environment. So that's something that we keep working on to increase those capabilities. Okay, last but not least is what we call Aireon Flow. And that's really the creating a better predictability for when an aircraft is going to enter your airspace. So I'll give you the example on the next slide of Eurocontrol. Eurocontrol is kind of an overlaying European organization that manages, doesn't manage, let's say, tactically the aircrafts that are flying in European airspace, but they're looking at it from a network point of view. Should have had more coffee, I think, this morning, so sorry for that. But so they're operating the European network, so they are looking at, okay, which aircrafts are flying from airport A to airport B, how are we managing that? They're giving slots to people to kind of adhere to make sure that they manage the network as efficiently as possible. They decided, it's going to be almost 2 years ago, to use our data to increase predictability. So think of it this way, what you see, everything, let's say, that is in the middle of my slide, is their area of responsibility, and they would typically have surveillance capability in that area already before they were using Aireon. They are basically kind of getting interfaces to radar feeds coming from France, from Germany, from Spain, to kind of paint the picture of who is flying in the airspace. Anything outside of that center area, so everything you see here colored in red, they would really don't know exactly who is flying where and when and how. So what they've decided is to create a ring, if you like, of 6 hours outside of their current area of responsibility. And we are feeding them data for aircrafts that are inbound European airspace 6 hours before they are actually reaching the border of the airspace. So this really helps them because of this better predictability. They can plan much more efficient. They can have more people in those like flow management positions. They understand whether there's going to be congestion in specific pieces of the airspace much sooner than what they knew before. So they can actually already anticipate that traffic and manage the traffic in a more efficient way. So we're seeing, as is mentioned here on the slide, about 20% of operational improvement in terms of efficiency just by adding, let's say, that our data to their current system to create that better planning horizon of 6 hours that they didn't have before. Another example is a customer that we have. I gave you the example of ASECNA before. This is in the African continent, where they are starting to do exactly the same. So they also said, we want to have a better planning horizon, and this way we can manage the airspace much more, let's say, efficiently, with less delays, less actual flight time for every flights than what they were seeing before. Again, and it comes with a potentially with like a list, like you see here, a very basic like demo capability. We're also partnering with other companies that are very strong in actually having the platform that does air traffic flow management, and then we add our data to that platform so they can then provide that to their customers. And I think by this, we're at the end of my presentation. So I'd like to thank you for your attention.